Very good morning, everyone, respected IPTA committee members and the delegates in the conference. I would like to take this opportunity to talk about how AI can be utilized or digital transformation will be possible by strengthening process controls and progressing towards the smart manufacturing. Before starting the details of my presentation, I would like to take this chance to say how ABB can support pulp and paper industry across various value pillars, right from asset performance improvement to process performance excellence, operational excellence, as well as sustainability improvement, and latest Gen AI based solutions for workforce skill enhancement also, all through cyber-secure solution. For today's topic, I would like to talk mostly predominantly on the process performance excellence related solutions. But because we are talking about process performance, I would like to just start with how a typical day of a process engineer looks like in a pulp and paper industry. So with all the enthusiasm, for the orders that they receive, they make it following all the SOPs and all. Jumbo is made, but when it is sent to the quality lab for testing, there is high chance that he or she will hear there is a quality disturbance that is there and the product is not meeting the quality. Then they go check the trends. Maybe if there is a loop problem, they try to fix it with the instrumentation engineer. When they are trying to fix it, there can be a paper break or there can be raw material availability issue. Pulp mill, there is a problem, some issue happened. And they maybe also need to address issues with respect to customer complaint. There's so many things they have, and to solve these issues, generally what these teams will do, they form up teams, they run some campaigns because loops are not performing, all loops should be in auto, or let us take an FI project, try to do some statistical analysis, fix the problem. All this will be done, but many control charts also they do and try to keep things under control. But by doing all this also, what will happen? Usually the results are good because a lot of initiatives have been taken. There will be improvement in the process, but after 6 months or 1 year again they will repeat. This we will be experiencing many a times. The reason for this is most of the actions that we are doing are reactive, and most of the controls that we are trying to put are also manual intervention related. You make some controls in action, but you will be manually monitoring whether they are in place or not. For this is the place where things are coming back. For this we can take help of AI. AI can help solve the problems with respect to PID loop level to your entire plant level, plant in the sense sub-process level like cooking, bleaching or paper machine and all. And also it can help to optimize and fix the issues with respect to your entire mill level. That is where AI can help. So to start with, why I am talking about starting with process control layer, because control loops are very, very important in paper industry, because paper is a huge continuous process industry, and in any mill you take, there will be at least 500 to 5,000 control loops that will be possible given the size of the machine or size of the factory. So in this, the study says at any given point of time, if you see how many loops are fully functional, you may observe only 30 or 25 to 30% of the loops are fully functional, but remaining things have some or other problem. But they don't create a major havoc, so we continue to run our plant like that. So even though you fix this problem, tune the loops, but after 6 months the problem can repeat. The loop performance will keep deteriorating. To address this, and because you're running your mills with this not suboptimal tuned loops, the major issues that can happen is your process can be having some disturbances, quality disturbances will be there. Not only that, because of this too much oscillations, you may be doing some excess dosages also. This will be giving a cost implication. For this, today there are platforms like Loop Performance Manager. This can integrate control loops. This is actually an IoT platform, and this can integrate all your control loops even at a plant level, in the sense at a manufacturing paper machine level, or at a complete factory level, or if you have multiple factories, all these factories loops also can be integrated into it, irrespective of whatever DCS it is. And then this will scan all the data from this loops, and it will say whether the problem is with respect to tuning, or is it with respect to the control wall, or it is with respect to the sensors. And it will give a beautiful dashboard like this, where instrumentation and process engineer will know which are those loops which are of priority to be addressed, fix those problems, and then you can go into the loop tuning. Even loop tuning, people used to do bump tests and It can capture the tuning parameters, and those tuning parameters can be simulated and checked whether the response you want is with respect to, whether you want a slow response or faster response. You can choose it and then deploy it into the DCS. And this is like a three-stage implementation. First, you can do the complete loop audit and then fix the physical problems first. Don't jump into fixing the tuning. Then after fixing the physical problems with respect to control valves and sensors, you have to fix the tuning part and then continuously monitor them so that whichever loops are having problems which pops up in this dashboard as the critical ones to address, you can address those. And here most important thing is your plant engineers should learn this, utilize this tool to learn how to do loop auditing and tuning so that they can do on themselves and continue to sustain the benefits. Now that the loop, PID layers, the process control layer is well managed, all level 1 controls are fully functional, mills can look at progressing towards the level 2, where the advanced process control comes into the picture. So you can see here, most of the time, because your loops are good and your process engineers are well equipped with the design parameters and how to run the process, they follow all the constraints and try to operate the plant in this region. But actually the performance optimization is possible when you are operating in here, most of the time you try to operate the plant in this region, but actually the economic optimum, the real savings happen in this place. But through normal DCS controls, you will not be able to reach to that level. That is where APCs can help. Why they will be able to help is because APCs can give a control action by predicting the future performance, how the mills need to be, how the process operates in the future. They predict it and give you the control action as a closed loop to the DCS. That is where it can help. And today's technology in APC is now even enabled with machine learning also. So whenever your model deterioration happens, it automatically detects and retunes the model. That is the latest APCs available. And especially this slide you might have very familiar because yesterday also many speakers talked about. All these APCs are individual process level, like for bleaching, cooking, paper machine, there will be individual APCs. And now I would like to just deep dive into a bleaching APC. So why bleaching APC is required? To maintain the pulp brightness of a final pulp in your pulp mill. The major goal is to ensure that there is no variability in the brightness as well as your copper is also stable. These you will be achieving by manipulating the bleaching chemicals. But when you do this, sometimes there will be mills which may not have this high expensive like brightness or copper sensors. This APC solutions has the facility of a soft sensor with the historical Excel based data that you have with respect to the lab measurement as well as the process sensors. This soft sensor capability in APC will help you develop those sensors, and those sensors can be used in implementing the APC control. And if you see, suppose if you don't have an APC but trying to address the bleaching chemical adjustment to ensure like brightness is well maintained, generally what happens, the change in the chemical that you are doing will reflect into bleach brightness improvement only after 5 or 6 hours. When you're doing this with DCS control, you do the action now, but you have to literally wait for 5 hours. You don't know and you keep on manipulating these variables. So what happens, there can be an over and under dosage happening. That is where APC will again help, because this will predict the future brightness and then give you a control. So this is the need for having an APC in the process control, process-driven industry like ours. And all these APC solutions are called as expert optimizer solutions, and this is also a 3-step implementation. Most important thing is you have to do a fingerprint audit, assess whether there is a capacity, the opportunity to improve in your mill or not. Once you assess it and agree upon it, implement solutions like expert optimizer or any other APC and develop, this has to be done collaboratively with the plant engineers as well as the experts, and do the best fit control strategy for your mill, and then also ensure that these APCs are very much in action. For that, like latest technology is available which will continuously monitor and tell whether your APC controls are in action or not, so that the benefit benefits can be sustained. Once this individual levels, once the individual processes like cooking, bleaching and all are strengthened, then we can look at moving to the level 2 controls, level 2 stage in this ISA pyramid, and look for some digital twins or mill-wide optimization solutions. You can ask, like, because individual processes are very stable, then why do I need to have another mill-wide optimization? Because you fix the problem in one mill or one process, but there is a heavy chance that, the next nearby process is deteriorating, because the actions that are doing here may be having an adverse impact on the nearby process. And this is where the mill-wide solutions, mill-wide optimization solutions will come into picture. And this will not only look into the process layer, but this will also take inputs from the MES layer. It will connect to your production schedules, your grade schedules, and accordingly it gives the corrective actions. So these modules, this sort of application come with multiple modules. The most important feature that is there in this plant-wide optimization or plant optimizer is the bulk tracking application, which will give complete genealogy of the final pulp you make, a pulp bale, dry pulp that you make, or the pulp that is going to the paper machine. If there is any issue, it can be traced back from that level to the wood chips that are being fed in which batch of wood is used. Complete traceability will be possible. And this also gives a continuous optimization view, wherein when you want to run a plant, at what level your digester production should be maintained or pulp production should be maintained, taking into control how your paper machine draws or how the liquor tank levels are and all. Complete visibility will be given. And this is like an AI-driven recommendations to the person in the mill who is operating your, completely coordinating the pulp availability for your mills. So that continuous optimizer is available. And in addition, this is also a digital twin, and this can help simulate the conditions. Like, for example, there is a paper machine which is going to stop in next few hours. Then how to really run my entire pulp and recovery process in a very, very optimal way, maintaining all the levels and all the production rates well within the LSL and USL. Some sort of recommendations also will be given by this. Now that I have explained about various solutions, I would like to talk about a few case studies here, which are implemented through the solutions I have explained. In one of the integrated pulp mill in North India, we have implemented a loop performance manager. Here, around 300 loops from various processes, like pulp mill, paper machines, and even boilers were connected. And these are also from different makes, they were connected, and loop performance manager is implemented. And most of them, we observed, like, after implementing this solution, variability has come down by 50%, and most importantly, the time to target. When a set point change is given, how fast the measured value is reaching the set point, the time to target also improved by 50%. You can see here in this chart, like, how the performance improved. This is for an evaporator, and this is what an improvement we observed in a paper machine just consistency. And next, there is another case study where we implemented expert optimizer line in one of the South Indian mill. And here they were facing problems like high fuel consumption and too much variation in the process, and also ring formation sort of issues they are facing. Expert optimizer line tune is implemented, and the mill experienced a 5% reduction in the fuel consumption, and also the key parameters like feed temperature, line purity, these variability in these parameters also decreased drastically. So now that I have told, like, various solutions are there, and everyone knows this pyramid, like level 1 to level 4 in the ISA pyramid. So you can ask me, like, where to start, because everyone want to implement AI. So how to start implementing AI? That is what first and most important thing. We have a lot of sensors, DCS and all, but if somebody want to do a digital project or a data analytics project, to give the data, there will be a big struggle. That is where ensure that all your data is integrated and stored and made available for your transformation journey. And then focus on the level 1 controls. Ensure that all your PID loops are well managed, and for that also platforms and tools are available, which I explained. And once your DCS or PID loops are all fully functional, then you can progress towards implementing APC. And today ML-based APCs are there. These are more robust and more dynamic, so that you need not worry. You implement an APC and later it may may not work well. And then we can start moving towards smarter manufacturing. If it is an integrated pulp and paper mill, then you can implement mill-wide optimization solutions. Or if it is a normal paper mill, there is no integration, but it's a large mill and too many complex products you're doing, then you can implement a manufacturing execution system. This is where you can move towards smart manufacturing. So I can say, like, for AI journey, we should start with process control and then strengthen it and move towards the smart manufacturing. Thank you.